Hello everyone, welcome to the channel. On this channel I mostly do flying in flight sims using VR and custom forced back devices. I used to do some videos of flying in reality back in my home country, but it's not the case anymore, at least for now. In this particular video I'd like to talk about flight controls when flying piston engine aircraft, which normally don't have any boosters. It's not a secret that flying fly-by-wire F-18 with a table-mounted spring-loaded joystick is not a big deal, even if it has small range of movements and very weak loads, since fly-by-wire will smooth the ride for you and will keep you out of trouble and will prevent busting of all limitations. Well, it's not the case for the aircraft with the direct control. I know maybe a few people who fly P-47 in Spitfire in DCS with no curves, and maybe no one who is capable to do it with Mosquito. It's just because these aircrafts are built to be flown by stick and rudder force applications instead of just displacement. That means when airspeed is getting higher, the flight control sensitivity by displacement is getting ridiculously high. And what compensates that is that tremendous growth in the control loads. Control loads are increasing proportionally to the square of the airspeed, which basically means that forces which are centering your flight stick and rudder pedals on the speed of 40 miles during the takeoff roll will be multiplied by 100 at the speed of 400 miles. That simple idea gave us realization during early days of FFBeast project that for proper simulation of loads on the controls, we have to get a wide range of force moments from forced back devices. The direct forced back commands coming through the DirectX protocol are inadequate for proper simulation because they were never designed for that. They're built to accommodate low-end devices such as Microsoft forced back joystick, and most of the time what we can use from it is just a force center position and the sum of periodic effects such as stall buffet. Let's have a look how can we replicate feeling of the aircraft on flight controls at this very challenging example, which is Mosquito by Eagle Dynamics. And here we are running the FFBeast commander, which basically the software where we can dial all the forces for our FFBeast devices, and we can use the previously saved profiles for any simulator and any specific model in it, and we can also check this checkbox for enabling the automatic profile activation. Let's say today we're talking about the Mosquito for DCS. That is why it's already created previously by me and selected for now. I'm not using the telemetry source DCS, I'm using the debug just for now, just to show you the capabilities of this software. And we will start with this folder elevator. For this specific channel we can use any effect we wanted, and then we can add the selected effect. You can see already selected and effects for this channel by me previously, and we're gonna start with the DirectX standard FFB. As I told you before, we're going to use the total effects range of trimmer effect. We just needed to have this trimming center position moving or shifting. Then I would like to talk about these miscellaneous smart dampers. We are using the total effect strength of 100%, and then this one static dampening. So this static dampening, it's the amount let's say of resistance you have to overcome when you moving the stick back and forth in the elevator channel. So this amount of resistance, it could be dialed, keeping in mind what type of aircraft we are dealing with. Let's say Mosquito, it's pretty long airframe from stick to the elevator, and we do have very big elevator, which I assume has some mass in it. So that is why this one dialed to 14 to have this feeling of inertia of the flight control movement and some stiffness coming from the friction in flight control. So that is why we are you know, based on my background flying different aircraft and looking at the general airframe, like an airframe in general, we can assume what resistance we can have in this particular channel for these particular flight control surfaces. Also, if you do have some numbers or let's say you've got access to the very specific documentation or the even the real Mosquito, you can provide this information so we can dial this control to match perfectly the real aircraft. So based on all of this information, we dial in this resistance. Like if you're using the very light plastic stick, you can move it almost instantly, and it's not a case for the real flight control for the real stick, and the same it works for the FFBeast when you dial it dialed it perfectly, you know, to match the real aircraft. So the dynamic dampening, it's kind of complicated. It does have calculation of the like mathematical dynamic dampening. Let's say you are flying at the high speed and you pulled a little bit of the stick on the stick, and then you released it instantly, and it will go to the center position. And if you don't have this very specific dynamic dampening, which it calculates the amount of force you applied previously to get it out of the center, and which is not anticipating the speed of coming back to the center position, it will overshoot the center position and it will start wobbling around the center or oscillate around the center. And while we do have this implementation, it's not the case for FFBeast. Then I would like to show you the miscellaneous elevator weight. This one dialed for 8 for this particular aircraft. So elevator weight, if we can see the Mosquito on the ground, like the real one, you can see the elevator in the down position. That means the stick folds forward. Now I'm using debug as a telemetry source just to show you how it works. I will go for G-force equals 1. So that's the amount of G-force we have when we're standing still on the ground, let's say on the apron. And you can see now this weight of the elevator overcomes the stiffness of the flight controls linkage we talked before, and the stick falls forward. The elevator goes down. It also depends on the aircraft. Some aircraft use counterweights to zero these effects, but some of them even has bob weights to emphasize the weight of elevator effects, you know, to help pilot to overcome those high G's or over G's when the flight control is not heavy enough, and when the pilot has to pull some G's. Basically, you can see here, if I'm dialing like G-force 5 now, it will fall rapidly forward. So I have to counteract to hold it still. That means when I'm pulling on a stick and building up some G's, I will have to counteract them as well. So that's how it works. I don't know how specifically it works in this particular aircraft. I don't have any specific, very detailed documentation about this one, but as I told you before, if someone has this or access to the aircraft, they can provide the information. We can dial these FFBs perfectly to match the real thing. Also, the prop airflow, you can see I dialed it here. If we can look at the airframe itself, let's say in DCS, we can see that the stabilator and the elevator itself, they are not affected that much like they are affected, let's say, with the P51 or P47 when the prop wash goes directly through the horizontal stabilizer. And but we also can see that the prop wash from both engines will affect the elevator itself. Let's say if I will increase. If I go to the debug telemetry source now, and I will switch it to DCS, you can see the stick went a little bit backward, just because even on the idle, I've got some prop wash coming into the elevator. So right now, if let's say I'm applying some brakes and I'm applying some power, you can see the stick moves backward. So that is why we still have some prop wash. Yeah, and that is sorry about that, folks. And this one is more interesting one, the spring airspeed. The airspeed, as we talked before, it is equals, so the airflow creates the force you have to overcome when you move in the control surfaces, and this force is equal to the square of the airspeed. And the way I'm dialing it, it's I have to get the maximum of my FFBeast torque to be reached when the flight control is clipped in DCS. Just let me show you. You know, when you're using the DCS and you can code up this diagram, flight control diagram, by pushing the combination of right control and enter, and you will see in the left lower corner this diagram. This red diamond is a visualization of your control stick. And when you're flying at a high speed and you pull in the stick, let's say rapidly, or just pulling on the stick, the way, so they basically, in Eagle Dynamics, they have calculated what the amount of force has to be pulled to get the elevator in this position, and they have calculated all the numbers, and they know, let's say there is a deflection when the force is high enough that the pilot is not able to overcome it. So the way the position when you can see your physical joystick is starting to deviate from the position of the 3D stick in the cockpit, or this diagram, diamond-shaped diagram on the left, that's the control clipping. So I'm dialing the maximum torque of my FFBeast, which is around 50 pounds in a pitch channel, to match these criteria. So for this particular aircraft, when you deflecting it like so, at the speed around 300 miles, you will get your maximum force, which means, let's go back to the debug. Let's go to debug. Now I'm using the GeForce One. So we're using debug, and now I'm dialing this, let's say 500 kilometers per hour, so which equals around 300 miles. And if I'll measure the forces I have to apply, just let's say for the 1 inch of movement, or to get this diamond shape like out of the center I showed you previously, it shows I have to pull 40 pounds to get there. That's how it works, and that is why it's now so easy to control this Mosquito without any specific curvatures in the flight control. You just using the straight line for the joystick, no curvatures at all, and you're using this force feedback, like the real implementation, like in a real aircraft. And that is why even the slight displacement from the center position causes you like a lot of force, and you have to pull or push a lot to, you know, to move the aircraft. That's how it works. Let's go flying to see how it works in flight. Alright folks, now we are flying in Mosquito in a level flight. Now we are accelerating, building up some speed, and I will trim the aircraft to keep it in level flight. It's kind of difficult for me to be flying on a flat screen. Normally I'm flying in VR. So the aircraft in a level flight, and you can let go of the control. No oscillation, no wobbling whatsoever. You don't have to use any curvatures for your flight control because the aircraft flying by itself. So the flight control stick, it's solid enough, stays in the center or whatever the trim position you put it, so you can let go of the flight control. It flies perfectly even without your actions. While the speed is changing, we have to apply some trim to retrim the aircraft to keep it flying in a straight line. Let's build up some speed by diving, and I'm gonna show you how this clipping works and what amount of pulling or pushing you have to apply, amount of force of pulling and pushing you have to apply to keep the aircraft flying on a high speed. Let's say I haven't been retrimming the aircraft, so I have to push a little bit on a high speed for now when we're close to the ground. So now if I will trim this aircraft, so I don't have any trouble to control it. So there is no oscillation or wobbling. The solid stick stays in a trimmed position, no problem whatsoever. So even you using your gun buttons, you know, to gunfire or machine gun fire, you can do it easily. It won't affect your aircraft flying, because that's the way how it works in a real aircraft. It's not like you're pushing the cannon button and your aircraft just flies away from your target. So you have to apply some amount of force, which is on a high speed very pronounced, to get your aircraft turning. So that's the way. I also have the controls, some force on the FFBeast rudder, so it's kind of replicates the real aircraft when you're flying it. When we're looking on this flight control diagram, we can see, look for it. When you're pulling very hard, you can see the 3D stick and the diamond red diamond stopped moving, so that means that clippings. That's the point we are looking for dialing the maximum torque for our FFBeast device. So Eagle Dynamics, they know the calculation they're doing, they know the amount of force has to be applied on this particular speed by the pilot, and they let you know that this amount of force you cannot overcome. So that is why we're using it kind of like a measurement where you have to apply the maximum torque of your FFBeast. So that is how we dial it. For this aircraft, when you're rolling it, so you can't really see the clipping in. That is why I'm not using the maximum torque for the ailerons for now, at least for this speed. In particular, this aircraft doesn't have very heavy ailerons, but it does have very heavy elevator, which you can't feel when you're flying the spring-loaded joystick or any other FFB devices if it doesn't provide appropriate forces. So see, no problem at all, hands-free flying. So basically, that's the normal way how the aircraft flies. How many Gs do we pull right now? 3 Gs for now. So it's not that easy when you're on a high speed to pull even 3 Gs. That is how it works. And remember, when you put in the gun sight on your target, do not hesitate to push all the buttons, to shoot at it, because it won't affect your flight controls. Well, let's say now we are climbing, let's do some maneuvers. It's very difficult for me to fly on monitor, not in VR, but I can do anything for you guys. So that is, we get into the low speeds, and you can see that the ailerons, they are very weak for now, very loose. It feels loose. We have to retrim the aircraft. You can see the vibrations right now coming through the stick, also through the pedals, and I'm just letting it go. It flies by itself. It flies from the pre-stall regime. So it's not a problem to be flying with the appropriate forces on when you're using, let's say, FFBeast. Thank you very much for flying with me today. Thank you very much for your patience, for listening for my terrible accent. See you next time. Bye.